everyone, welcome back to my channel. In this video, we will learn about different laws of chemical combination. This lecture is purely on the demand of the students. They want me to make the video on laws of chemical combination. So if you want any topic of biology and chemistry, do comment in this video, and if you like my videos, do subscribe my channel. So let us begin. So there are basically 4 laws of chemical combination that are very important for you to understand. So number 1 is law of conservation of mass. What do you mean by conservation? Conservation means that the mass is conserved, means neither the mass is created nor the mass is destroyed. It was given by Lavoisier. This you have to remember. Okay, according to this law, during any physical or chemical changes, total mass of reactant before the reaction is equal to total mass of products after the reaction. That is, matter can neither be created nor be destroyed. Okay, it means that the mass of the reactants before reaction is equal to the mass of the product after reaction. Easy. For example, if we are having any physical change like water, solid will convert into water liquid. If we were having 10 gram ice, then we will get 10 gram water. So this is basically law of conservation of mass. Okay, similarly, if we are having chemical change, for example, we are having NaCl, we reacted it with AgNO3, then we will get NaNO3 plus AgCl. Here AgCl will be a white precipitate. So if we will calculate the mass of NaCl and AgNO3 before reaction, that will be equal to mass of NaNO3 and AgCl after the reaction. Now let us see the limitation of this law. Limitation. The limitation of this law is in the case of nuclear reaction, because in nuclear reactions not always the mass is conserved. Mass is not conserved because the mass of the product, here mass of the product is slightly less than mass of the reactant. Okay, and this mass is converted into the energy. According to the Einstein's equation, E is equal to delta M into C square. Means the change in mass, means the difference between the mass of the reactant and product into the C, means velocity of light square, will give you the energy generated, due to which nuclear reactions are hazardous. So you have to remember the limitation also. So next, let us see the second law of chemical combination is that law of constant composition. Law of constant composition. According to this law, a pure compound always have same elements in fixed ratio by weight. Okay, let us just repeat that according to this law, a pure compound always have same elements in fixed ratio by weight. Let me just tell you with an example. For example, we are having CO2. CO2. CO2, we are having carbon and oxygen ratio 3:8 by weight. Okay, how 3:8? Because carbons, because carbon's mass is 12 is to 2 oxygens we are having. So that will be 12:32. So we will get here 3:8. This is a in the carbon dioxide ratio of carbon to oxygen by weight. According to this law, according to this law, whatever be the method we use, whatever be the method we use for preparation of carbon dioxide, always this ratio will remain the same. That's why it is called as law of constant composition, because the ratio between the weight will remain constant. Okay, so there can be two methods for any methods, many methods for preparation. Like if we heat calcium carbonate, then we will get calcium oxide plus CO2. Here CO2 is formed. Or in the case of respiration, this is glucose. This is respiration in the presence of breakdown of glucose in the presence of oxygen. We will get CO2 plus H2. In both the cases, the preparation method is different, but the ratio of carbon to oxygen still remain the same, that is 3:8. So this is a second law. Okay. Now there are also limitation of these law. Limitation. Number one limitation is it fails in isotopic cases. What are isotopes? Same atomic number, different mass number. Because here is the ratio of weight. If we will be having C12O2 or C14O2, here ratio will change. Here ratio will be 12:32, but here the ratio will be 14:32. So this law fails in the case of isotopic compounds. This you have to remember. Okay. Next, our next law is law of multiple proportions. This law was given by Dalton. This you have to remember. According to this law, when two elements combine to form two or more compounds, then weight of one element which combines with fixed weight of another element have simple whole number ratio. What do you mean by this? It is just, I will tell you with an example. For example, let us just take two elements, nitrogen and oxygen. There are many compounds that can be formed like N2, NO, N2O3, N2O4 or N2O5. In this, all the compounds, there is different weight of nitrogen that is combined. Okay. For example, in N2, we are having weight of nitrogen 28, oxygen 16. In the case of NO, we are having 14 for nitrogen and 16 for oxygen. In the case of N2O3, we are having 28 for nitrogen and 48 for oxygen. But according to this law, if we fix one element, if we fix the weight of one element, then the other element will remain in the simple whole number ratio. This you have to remember. For example, if we fix the weight of nitrogen, means if we do here fixation of nitrogen with 28 only, then you can see that the weight of the oxygen will also double here. It will become 32. Let me just give you an example. Again, we'll take the same compounds N2, NO and N2O3. If we will fix the amount of weight of nitrogen, for example, in the case of N2, we fixed it to 28. We fixed all, in the case of all, we fixed it to 28. Here we will get 16 weight of oxygen. Here we will get double because we have doubled both of them, 32. Here we will get 48 only because we are having already 2. So now if we will find the ratio of the oxygen's weight, then you are simply seeing that it is 1:2:3. It is 1:2:3. So we have fixed the nitrogen weight, but now the oxygen weight is in the simple whole number ratio. So this is the law of multiple proportion that was given by Dalton. It has no limitation basically. That means it always holds true. Next, and our fourth law of combination is that law of reciprocal proportion. It was given by Richard. Scientists are sometimes important for you to remember. So it was given by Richard. Okay. According to this law, ratio of weight of two elements A and B combined with fixed weight of C is either same or in the same simple whole number ratio with which A and B combine together. Let me just clarify this law with an example. For example, we are having 3 species here, A, B and C. If A and B combine with simple whole number ratio, then either of them, if they will combine with C, they will have the same whole number ratio. Means if A and B are combined in 1:2, then if A and C will combine, then it will be also simple ratio. Or when B and C will combine, then it will be also simple ratio. So let us take an example over here. For example, if we are having hydrogen and oxygen like ABC, let me just write here ABC, hydrogen and oxygen. And let us just take the C element over here, carbon. So when hydrogen and oxygen combine to form H2O, then the ratio is 1:8 by weight, we know. Now if H will react, H will react with C, keeping the O fixed. We have fixed the O here. When H will react with C, then we will get CH4, we know, which is methane. Okay. And here the ratio will be equal to 12 is to 4. Means 3 is to 1. So this is a simple whole number ratio. Okay, so let us do the next case now. We were having A, B, C. Let us just write all the things again to clarify. A, B, C. A was hydrogen, oxygen and carbon. Now we have done this. Now let us just do the reaction between O and C, keeping the hydrogen fixed. We will keep the hydrogen fixed and O and C will react to form CO2. Here the ratio is 12 is to 32. Or you can say 3 is to 8. Then it is also a simple whole number ratio. It may be either same or it may be simple whole number ratio. Now let us see the last case. If we will keep C fixed, then we will get water over here. Then in water also, we are having the ratio 1:8 again. So this is verified. Law is verified. Basically, let me just tell you this law again because it is a little confusing for students. See, if we have seen here, in the case of CH4, we were having hydrogen in the ratio of 1. And in the case of CO2, we were having the oxygen, carbon to oxygen ratio is 8. So here we are having hydrogen 1 and oxygen 8. So when H2 will be formed, means we have fixed the C at 12. So then the H ratio O is 1 is to 8. And when they combine to form H2O, then also their ratio is 1 is to 8. This means that the law is verified. I hope you like this video about the law of chemical combination. If you like this video, do press the like button and also subscribe and hit the bell icon to get the notification at first. So if you want another videos, you can comment down your doubts and your topics which you find difficult. Till then, keep liking, keep sharing and keep subscribe to my channel for more authentic videos. Thanks for watching.